In this video, I'll go through a quick example of parallel and series combinations of inductances and how to find their equivalent. So let's assume we have an example like the one I'm showing on this slide, a circuit of inductances, in parallel and series. So I have L1 through L6 inductance basically in millihenries, and I want to find the equivalent inductance. So the first step is notice that this point here and this point are the same potential. So that means this here is just one point basically. And the same thing here, this point all the way to this point are at the same potential. What that means is L6, L5, and L4 and L3 are all in parallel. So what I'm going to do, I'm going to start from the right and work my way to the left. So L6 is in parallel with L5 and in parallel with L4. So inductances in parallel, their equivalent is 1 divided by 1 divided by L6, 1 plus 1 divided by L5 plus 1 divided by L4. If you do the math, that comes to 66.67 millihenries. So basically, I found the equivalent of the inductances up to this way. So I call that L equivalent 1. So now L equivalent 1 is in parallel with L3. And also with L2 because this point here and this point are the same potential because there is nothing connected here. So this is really just one point basically, as if you have something like this, basically one point, and you have something like this where you have L2, L3. Then this point and this point are the same basically. So then it's just one point here, and basically they're in parallel. So that's how I know they're in parallel. So I do the same kind of technique, 1 divided by the sum of the inverse of all the inductances involved in the parallel combination. So after I do the math, I get 31.58 millihenries. So now I get the equivalent up to this point, basically L2, from where I started. So then that equivalent that I called L equivalent 2 is in series with L1. So the equivalent inductance of this circuit is L equivalent 2 plus L1. So if you do the math, it comes to 131.58 millihenries. So again, the technique is you start from the left and you try to identify, for instance, you choose one inductance and you say, okay, is it in series or in parallel with the next inductance? So the way you know if they're in series, obviously, you can look at it one way. If the current flows through, if it's injected at a point, is the current going to be divided between the inductances, or is it going to flow in the same inductances? If it divides, that means those inductances are in parallel. If the same current flows through them, that means they're in series. Another way to look at it, just like I did for L2 and L3, they share 2 points. That means they're in parallel. So if I inject current here, for instance, at this point, some of it will flow through L2, some of it will flow through L3. So that means they're in parallel. Thank you and have a great day.